Okay. My name is Sushila Ratre and I'm making this presentation to understand the spatial temporal attention mechanism for trajectory prediction for the vehicles, or we can consider this type of spatial mechanism for the trajectory prediction in the autonomous vehicles. So here the spatial and temporal attention mechanism. When we are creating the model for the trajectory prediction, like we have to select the path of a autonomous vehicle. So that time we can include the spatial and temporal attention mechanism. And this spatial and temporal attention mechanism will play very important and crucial role in what sense? To improve the accuracy and efficiency by selecting and focusing the important patterns or important features from the data set. So what is spatial attention mechanism and what it does? So basically spatial attention mechanism focuses on the most relevant spatial relationship between the vehicles, road structures and its surroundings. And also it enhances the model's ability to recognize interaction between the neighboring vehicles and lane changes. So here let's consider we have the lane, and in this particular lane, if we are considering this is our vehicle 1, this is our vehicle 2, and another vehicle we have somewhere here in this lane. So if we apply the spatial attention mechanism to predict the trajectory of this particular vehicle V1, so it will give more weightage, more focus on this nearby vehicle, So that is related to the spatial attention mechanism, like how this particular vehicle V1 is related to the other vehicle on the same lane. So why it's important? If one vehicle is moving on the road, so what we can consider, vehicles do not move independently. Their trajectories are influenced by nearby vehicle. In the road, in the highway, if n number of vehicles are moving, so the movement of one vehicle is affected by the other vehicle. So that's why spatial attention is important. So spatial attention help the model prioritizing interaction, for example, merging, overtaking and braking. Again, it also helps to reduce the noise from the irrelevant distant vehicle. If one vehicle is far away from the target vehicle, that time that particular far vehicle will not affect the target vehicle. Let's see the example use case, like in a multi-lane highway scenario. We are considering the multi-lane highway scenario. So spatial attention ensures that the model gives higher weight. Here, this higher weight is related, this higher weight term is related to the neural network. When we will implement this kind of mechanism or concept with the help of a deep learning models, so weight mechanism is there. So it will give the higher weight to the vehicle in the same lane or directly adjacent or neighbor vehicle rather than distant vehicles with little influences. So it will give the more weight or more importance in the same lane to the neighbor vehicle to understand the driving pattern of the other vehicle for the trajectory prediction of the target vehicle. Another concept here we have the temporal attention mechanism. So temporal, like we have the spatial attention mechanism. Spatial is simply related to space or location or position of the vehicle. Temporal is simply related to the time step from vehicle is moving from one location to another location with respect to the time, or here we are considering the time in a millisecond. So what it does, it focuses on the critical time steps in a vehicle movement history. So here this movement is also one of the attribute we can consider, but yes, temporal is related to the time steps. And again, it helps the model learn long-term dependencies, like what will be the acceleration pattern, sudden stops, should it will apply the brake or not. So this kind of actions vehicle can consider when we apply this temporal attention mechanism. Why it is important? So here we can consider not all the time steps are equally important. But yes, recent moments are significant than distant past moment. It will affect from the recent moment, the previous moment, like previously 0.01 second, what was the moment of the vehicle. So it will affect from that time steps, and it captures motion trends and driving behavior more effectively when we apply this temporal attention mechanism. So yes, it will improve prediction by emphasizing sudden change, like cars slowing down. Slowing down, if we are using the slowing down word, so it is directly related to what features? Acceleration features. If we use the feature acceleration, it will increase the speed of a vehicle. It will decrease the speed of a vehicle by applying the acceleration. So here at the same time we have to check what kind of parameter we will use when we will apply this kind of concept. So here we can consider the acceleration, one of the feature that is available in the next generation simulation data set. Slowing down before a turn, that that concept we can apply. So let's say the use case, example use case, if a vehicle brakes suddenly, other vehicles, like in this road, we have one vehicle, and here another vehicle is a following vehicle. Distance is very less. Vehicle V1, vehicle V2. Let's consider this particular vehicle apply sudden brake. Then what happened? That time this V2 will collide with the vehicle V1. So in this kind of situation, V2 should apply the brake, sudden brake. So this concept, at what time vehicle V2 will apply the sudden brake, that mechanism we can implement with the help of a temporal attention mechanism. So if a vehicle brakes suddenly, the model assigns more attention weight to this event. This is one event, like V1 has slowing down the speed. That time also vehicle V2 will apply brake, rather than giving equal importance to all past moment. Like here we have to consider the moment also, but not all the time. So temporal attention is important when with respect to the driving pattern of the other vehicles on the road. So here fused spatial temporal attention, like we can combine these two concepts to improve or optimize the trajectory prediction. So combined spatial temporal attention mechanism can optimize trajectory predictions. How? By focusing on near influencer vehicle while considering recent motion trends of the other vehicles. Then reducing irrelevant information. It making predictions more computationally efficient and improve adaptability in complex driving environment, that is intersection with the other vehicles, the lane changing. So this fused spatial temporal attention is very important concept while while we are making the trajectory prediction models or algorithms to improve the efficiency, to optimize that trajectory prediction algorithm. So the conclusion is why it matters. For higher accuracy, obviously accuracy should be high, then better generalization and computational efficiency. So higher accuracy is what? Predicting a realistic future path by focusing on the important movement patterns. Not all movement we are going to consider, but yes, important movement we need to consider for trajectory prediction. Then better generalization, it works well across different traffic scenario, different traffic condition, like highway is there, urban street, urban environment is there. Then third one is computational efficiency. Avoid processing unnecessary data. So we are not going to process all the data. So indirectly it will reduce the cost of a computational efficiency. Like it will become the computational efficient and it improve the real-time performance. So in the next video, we will see what kind of features exactly we need to select at the time of implementation of a fused spatial temporal attention mechanism for the trajectory prediction. Thank you.